In this application, a sinusoid at a certain frequency will be drawn over a few periods. For the Python file, these are the imports. The application layout is based on float layout. We always need the app class to develop an application. We use several properties, so changes in their values will be updated. The clock class is used to control the timing of the drawing. We need the color and line classes for the graphic calls from within the Python code. The cosine and sine functions and the pi value are imported from the standard Python math module. This is the start of the root class. The first three values, phase, frequency and period, are used in plotting the sine graph. The parameter phase is the initial phase of the sine curve. It will be a value between 0 and 359. The parameter freq is the frequency of the sine wave. While the frequency could be any number, and for audio it is between 20 Hz and 20,000 Hz. But for the program we limit the frequencies from 0.1 Hz to 1 Hz, so the drawings can be followed in real time. The parameter per refers to the number of periods drawn. Here it will be a number from 1 to 10. The value dot time is the x-axis of the sine graph. The dictionary in line will be used to update the two lines in the unit circle. The dictionary in S line will be used to update the sine curve. We will show how we use these dictionaries for the drawing later. The Boolean value in disable go will be used to control the buttons, so they are disabled when sine drawing is in progress. The init function is called first when the root class is created. We always have to make a call to its super or parent. Since the root is based on float layout, the super is float layout. Next we draw two lines. The green line is always 1 unit long. It will be a line from the circle center. The red line draws the y component. Here the y component is 0. However, we will still be able to see it since it has a width of 4. These functions will be called from the Kivy file when a particular button is pressed. The 4 buttons control phase value. They will either increment or decrement phase by 1 or 15 depending on which button is pressed. The function onPhase is called whenever the property phase changes. That is, whenever one of the last 4 functions change the phase value. We draw 2 lines inside the unit circle. We first remove the 2 lines currently inside the unit circle. Next we draw a green unit line from center to a point on circle and a red line for the y component. The length of the red line is the value of the sine curve at time 0. These functions will be called from the Kivy file when the appropriate button is pressed. They will change the value of frequency or period within the specified limits. When the go button is pressed, this function is called from the Kivy file. It will remove any previous graph should it exist. Then the drawing dictionary is cleared. The initial point is drawn, then the clock is scheduled to go to a function go1 0.5 seconds later. At this point we disable the buttons, so they cannot be pressed during graphing. The only function of go1 is to call go2 at a rate of 60 Hz. In go2 we first calculate dot time, which is the cumulative time defining the time axis of the sine curve. The values x and y will be used for the 2 lines inside the unit circle. The value xs and ys are the drawing coordinates on the sine curve. The second half of the go function is the actual drawing functions. We update the 2 lines inside the unit circle. Next we add a point to the sine curve. We hold the references in a dictionary structure so we may clear them later. When dot time indicates we have reached final time, we reset the dot time variable, enable the buttons and unschedule any further 60 Hz go-to calls. The app class has to be created for any application. In the main code we start the application by calling its run function. For the Kivy file, two dynamic classes are created. They are based on the button and label class and define a fixed size. If we use these classes rather than button or label, we do not have to have any size rules. Next, the root is defined. A background bluish color covers the entire application window. Next, we draw a rectangle around where we will later place the phase value. We will also draw rectangle lines around where the frequency value and period value are shown. The circle line defines the unit circle. The last rectangle defines the area where the sine curve is drawn. Notice we use the line graphics function, so only the parameter is drawn. The first label indicates the value underneath is the phase value. The actual phase value is connected to the phase numeric property defined in the Python code. This will be shown within the first bounding rectangle. Here we define two buttons which will either increase or decrease phase by 1. Next, we have two buttons which will either increase or decrease phase by 15. We define the label with the word FREQ. It will be over the frequency value. The actual frequency value is placed inside this label. These buttons will either increase or decrease the frequency by 0.1. The PER label is shown above the PER value. The period value stands for the number of periods of the sine curve that will be drawn. The actual value of period is shown in this label. These buttons either decrease or increase the period by 1. The Go button is then shown. We will not use the My button rules since the size is different. When the button is pressed, it will call the Go function inside the Python program. This label will indicate the 0 time for the sine curve. This label will indicate the final time for the sine curve. The Python and Kivy files are on Blogspot.